Right, okay, so there's going to be a few changes, I think, for the near future. I don't think I'll be doing too many Arduino projects because I've got a bit of bad RSI, and it looks like I'm going to have to like basically stop typing for a while. So I can probably do a little bit. Like I'm going to finish off the display, the little Tetris game. Well, at least a little racing car game, because I've actually already done that, so I just had to print things out. So that should be okay. I can do a little bit of typing. I should be able to use my hands. This is basically a test to see how well I can do this. Probably shouldn't be doing this tonight, but hey, let's just do it. Anyway, we're going to do a new IC. This one here is the LM1830, and you might be wondering, what on earth is that? Well, it's a pretty old thing that's very hard to get. So it's in this book. It's in this. Oops, sorry, I've knocked the camera. It's in this book here, the Integrated Circuits Hobbyist Handbook, which is kind of a silly book, but I quite like it. And if you're looking up old ICs that nobody uses, it's a fluid detector. So this is the circuit. We're not going to do that one first. We're going to do the one that's from. Where did I put my giant book? I have my very old copy of Linear Data Book for the National Semiconductors. I didn't mark the page. Oh, there it is. I've opened it up a couple of times so it actually comes up on the right page automatically. So this is, there's a little, where is it? There's a basic circuit in here somewhere. Base low level water warning device, which uses an LED. So we might just do that one first. I don't quite have the right component, so I'm hoping everything works the way it is supposed to. But first off, let's put, and hopefully it runs from 5 volts. I don't actually check what it's supposed to come from. Let's just do that right this second. It says here plus volts. It doesn't actually say what it needs. Recommended supply voltage is 12 volts. Well, I don't have a 12 volt supply sitting on my desk. So we'll just have to make do without having 12 volts. This is not going to work. Alright, maybe I should have photocopied this first and then enlarged it. What a silly video. Alright, so we need a 510 resistor, which we're not going to have because I don't have a 510 resistor. We're just going to use a 470 ohm resistor, so we use one of those ones. And we need a 0.001 microfarad, which I think is a 103. This is a 1000 picofarad or 1 nanofarad capacitor, which I think is one of those, which is this one here, which is, these are these cheap ones that fall apart all the time. We need an LED, that's going to be easy to find. And over here this is 0.05 microfarad. And I'm just going to make that up. I've got these 203s. I think it has to be 503. That translates. I just looked up on the internet. I always get these things wrong. Does that make sense? So 50 with 3 zeros after it, which would be 50,000 picofarads, which is 50 nanofarads, which is 0. I think that's right. So, well, I haven't got that. So we're going to use a couple of 203s. To try and make that up by putting them in parallel and serial. And then I don't think there's anything else we need. This is not written in the way that the picture looks. That's not very helpful. This is going to be a bit of an annoying thing. So let's just first off. I've forgotten. This is they don't like this thing doesn't even have a. Oh, yes it does. This is a pretty old IC. So all right. So where's my little pin thingy? I've got a bunch of these actually, so I don't have to worry if I blow it up, which I probably will. Oh, I've got to be careful. I don't really think I can do this tonight. My arms are feeling a bit strange. Alright, so VCC. Where's my little pile of bits and pieces? Let's just read this thing off here. We'll put this one onto there. You can't actually see that, can you? Alright, this is why it's too late for this. Alright, that's VCC. Ground is miles away in the middle of it for some reason. I've got this around the wrong way, haven't I? I'm always doing this, aren't I? Well, normally I have pictures that tell me which way around the ICs go. and I've completely forgotten. I'm going to use this book actually. Hold on a second. Alright. No, I got it right. I was right the first time. So there you go. Hold on. Ground 14. This thing isn't laid out properly either. Where's a picture of the actual IC? Oh, here it is. Alright, well, we're just going to use this one. We're just going to use this one because it's much easier to read off. So the supply voltage, that's right. So I put it this way here. It will match the book. Ground, I'm going to use a very big wire for no reason, is here. Oh, it doesn't work. No. No, it's just okay. There we go. That looks right. There should be two in between. Okay. I'm going to knock everything onto the ground. Put that there. We're going to get this other book, and I'm going to put that on my lap, which you can't see. And then I'm going to read off what it's supposed to be. So it says here the timing capacitor goes between pins 1 and 7, which I believe will say on here something like oscillator capacitor and 1 and 7. Well, that makes sense. So we're going to use this thing. So the trick with this is it's basically for detecting whether or not these two probe sensors are touching water, or that there's water between them. And the only thing with this that's kind of clever is I think it oscillates the output. So it's basically a little oscillator. So that it avoids plating, I think I read somewhere. So I guess if you put a DC current and you have like that, so you could just easily make this with like a transistor, sorry, and use the water as a conducting piece of material with a high resistance, of course. But if you attach it to a transistor, then you'll be able to detect when two probes. You might make that with a transistor next time. So, but that's a DC version, and that causes electroplating or something over time, and so I guess that like stuffs up the contacts, and so it won't last forever. So, but if it's alternating, I think that's the whole point of this thing, is that then it is useful, and not like it doesn't electroplate. So hold on, we've got the timing capacitor in. So 13. All right. Well, we're going to have our probe wires first off. I do have a container, and I do have some nearby water, so don't worry about that part of it. So these are going to be my two probey things. One of these has to go to ground. So we'll make this one. This one's my ground connection. Right, and then the probe, the other end is going to go to pin number 10. Wait, this is ground in here. What? Well, this is interesting. This picture doesn't make any sense. Oh, it says detector input. Why am I reading things the wrong way around? I am reading things the wrong. Oh, I'm reading the opposite page. Sorry, you can't see that, but there's another page here, and it's got ground on pin 10. And that makes me confused. But pin 10 is actually over here, right next to ground. So that is going to be my detector. So when there's water between these two things, it should actually function. But also from pin 10 up to pin 13, we need 0.0 microfarad doodacky. So what I'm going to do is we'll just have to do it over to the side. I'm going to put two 203, so that's two 0.02 microfarads in parallel with each other. So when you put them in parallel, then you basically add up the capacitances. So that's a 0.04 microfarad, so that's a 403. And then we need so this is going to be trickier than I thought. Then we need another 5. We're going to do is try and get this as exactly as possible. That's not even words. 0. All right. I could get it on my little component tester wherever I put it, and we can see if we can actually make something that's close to what we want. But the idea is that we'll put those two in parallel, and that will add them up. And then, so we've got 403 here. and if you can see this, it's they're in like a thingy, what's it? Parallel. But we need to have 10 more, and I've only got 2 more 203s, so I'm going to put these two 203s in parallel, but together they're going to be in series. So when you put them in series, then you do a similar complicated equation like you do with resistors that are in parallel. But in this case, because they're the same value, then they're just going to be halved. So if we're going to have 20 203s, so we're going to have, not 20 203s, but if we're going to have a 203, we're going to get a 103. So that's going to be a 103 plus 2 203s, which is going to be a 503, which is the same as 0.05 microfarads. So this is my made up version with wires all over the show on a breadboard, which is the terrible way of doing things. But hey, what are you going to do? Not a lot, that's for sure. All it's got to do is make the little light come on. I'm pretty sure no matter what you do, this thing is probably going to reasonably work. I'm just going to be a bit annoyed if you actually do need 12 volts. Probably going to need that. And this is like probably designed for a 12 volt input. So this is all just a waste of time. That says 0.05 there as well. And then, hold on, the other side of this capacitor goes to pin 13. So that goes into there, and pin 13 is of course right next to the supply voltage. It says oscillator output. Alright, okay, weird. Who knows how this thing works? Oh, it's the oscillator output. Okay, I think it kind of makes sense. Well, why? Don't know, I don't know actually. Alright, well let's just finish this off. Where is my little pile of... they're right here. I was going to use this one. Now I just need a LED. And of course, as soon as I want one, there are none sitting around. But we will use a blue one, because blue is the color of water sometimes, and so the ocean. If we use a blue one, then we will know when there is water. I actually thought this would be quite a good thing. Really should make up a little simple thing sorry, that sits on the floor, that you put on the floor next to your washing machine, for example, so that hold on, it's got to go from VCC, alright, to here. Put it on there, and it detects when there's water on underneath it and sets off an alarm. Because I have in fact flooded my place by having the pipe from the washing machine not go to the right place. So this actually, the output of this goes to pin number 12. Pin number 12 is the output. So alright, so let's find pin number 12. That's miles away. Why did I put it all the way over there? Why did I use such a small wire? Alright, well that's the pin 12, and that's that bit there. I'm going to show you the circuit again in a second so you can see what I'm doing. And I think that's everything. Like, the other pins aren't connected to anything. So plug that in properly. Make sure it's on 5 volts. The light should come on because it's not touching any water, but we do need the battery first. So this thing here, the alarm goes off when it's not connected to something. So that's not so useful for making an overflowing, what are they called? Washing machine alarm, because it's you have to listen for the alarm to go off. You're like, oh no, there's quiet. That means I'm starting to flood my house. Alright, that battery has got a problem. Alright, so plugging it in and turning it on. And the light comes on, which is a good start because it's supposed to come on. But we're going to turn it off for a second. And then we're going to get this little thing here. Come back. This is such a silly video. And because I haven't actually tested this, I feel like I should get out that little component tester. Can I actually see it from where I am? It's normally sitting around somewhere. This is just I was painting stuff, and this is like leftover paint bits. But I've been using this to store water before, and the more contaminants, the better, I suppose. It will increase its conductivity. So there's a big list in these things. It says does not work with alcohol. It does not work with some things. It's better with, like, you know, that kind of water and this kind of water. Alright, and I've gone and put it on the wrong side. So here we go. This is my ground thing. That's just going to sit there. Alright, on the side. And this is going to be my probing device. And that's going to sit in there as well. So if I left it there, I guess it would rust. If I had a DC current going through it, I guess it would start to go funny faster. Oxidize or something, I don't know what we'll do. But with AC, everything's good and I can leave it there for years, I suppose. Oh, the light came on for a second and then it went off. Oh, and it came, oh, it goes, oh, it does work. Look at that. That was pretty sweet. Alright. So we can leave that there. So that's kind of fun. But the one in the book, so we can, anyway, we'll just do one more. So that was the circuit we just built, which you can kind of have a look there. So this is from the applications note. So I'm sure that there's no problem with me putting this on the internet. We'll make the one with the loudspeaker version. If you want to make it so that the light comes on when they're touching water, you just have to use basically an inverter with a transistor, which we might be able to try, but we're running out of time here. And I really want to do the speaker thing. Except, where did I put the speaker? Oh, no, 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 no. No, I knew there was something that was going to go wrong. I left it on the desk. I have to actually find the speaker that I put on the desk. I don't think we're going to be able to do it if I... Oh, there it is. Miles away. Okay. So we're going to use this little speaker. Which is in pretty poor shape. This is a very old speaker. This actually came out of a BBC microcomputer that had a very, very, very tough time in life, and was mostly melted and stuff. So it ended up in a bad place. But I've still got the motherboard, and I've still got the speaker here. And it has worked before, so I'm hoping it will work. It's not a very good speaker. The sound quality is terrible. But it's perfect for this kind of thing. Because I've got some wire on the floor. You can put these things in one end, and then you can plug it straight into a breadboard. So it's a nice, easy, breadboard friendly speaker that's actually got like burn marks on it. I got the motherboard. One day I'm quite keen on, where's the lid for this? I'm quite keen on recovering all the ICs from it by using a hot air gun. Because I saw someone do that on the internet, and it looks like, well, that's the best way of doing things, right? You can just melt them all off and they all fall off, and it's much neater and tidy than spending forever trying to desolder them any other way. So one day I'm going to do that and salvage all the ICs. So I need to bring back my book so that we can finish this off and just put on the speaker. So hopefully we'll get a nice 500 Hertz tone, which will be a lovely pleasant sound. We need a 1.5K resistor, which I don't have. Well, I might have. Hold on, what have I got over here? We've got a 1K, we've got a 2.2K. So I picked up these random resistors. Is this really that? It is, I guess it is. Okay. Hold on, where is... I don't really know what that resistor is. We'll just use a 2K one. No, we'll use a 1K one. Because that makes a lot more sense. Okay, these ones are like very old resistors that have been just sitting around, that I bought for like $1 from somebody, and they put them all in these little cases. I'm just going to double check that this is actually what it says it is, because you never can tell these days. Not that it matters. If it doesn't work, it doesn't work. Who cares? I mean, you just try something different. There's a lot of resistors around here. I can just put 3 of those. That's 1,000. Okay, we'll put 1,000, and then we'll put. This is right. It's right. It's literally sitting right here. We'll put one of these in. That will make 1,500, and we'll do it exactly as the picture says. Okay, so there's not much more to do. So we've got the 1 to 7 one, that's there. We've got all that business. So the only difference is that we're going to be putting the speaker in via pins 14 and 12. So first off, one of these wires is going to go to the positive. I have to do it that way, don't I? Alright, and I'll put, well, so far my arms are doing okay. So I'm kind of like, well, I really want to do a lot of coding at my point in life. And so this is bitterly disappointing. But I need to be able to continue with this. So I can't do anything stupid that would damage my muscles and my arms and my tendons permanently. So I'm just really going to have to quit doing much at all when it comes to programming. But there's lots of other things I can do that don't require me typing. And I can use my hands. I'm just worried. I've been using my left hand a lot, and I think I'm going to stuff up my left hand as well. So, alright, so the speaker is in there, and then the other one, alright, I'm a bit confused by everything here. Oh, that was a terrible wire, it broke. We won't use that one ever again. Alright, so we're going to change that over. How much time have I got left? I've got 7 minutes, we can do this. This is going to be fun. Oh, okay, these wires are so bad. Alright, I'm just going to look at the picture again. So 14 was the supply voltage. Oh, that's just dumb. I don't have to do anything. I don't have to do that at all. Alright, so what am I even thinking about? And 12 is the output, which is what we just did for the thing. There's nothing exciting in this at all. Nothing exciting at all. Maybe we can keep the LED there. So the LED is probably flashing as we speak. Well, it was flashing, but just super fast. So pin 12 is the one that the LED is already on. Why am I doing this? Why didn't I just plug? Oh my goodness. So I can, no, we need our little resistor thing. So we'll do it over here. Alright, so we put in the 1K, and then we'll put in a 470, so we'll get pretty close to the required 15K, 1.5K that we want. And then what was this plugged into? Oh, that's the probe. Right, okay. Maybe we should be using this one for the probe because it's a bit longer. Right, that one can be the probe. And then this can go all the way back to the thing. Alright, it's probably going to make a beepy sound. It's probably going to ruin all the fun because it's going to beep as soon as you turn it on, like it did last time. Which is sad. So what's that one? That's a 104. We don't need that guy. Alright. So I kind of want to, like, you know, have the suspenseful moment where you have it in the water and nothing's happening, and then you take it out and it starts beeping. But it's going to beep even though it's in the water, isn't it? It's just going to beep beforehand. Okay, here we go. This should work, I hope. What? Nothing happened. That's good. Still no beeping sound. What? Will that work? Okay, that's going to the positive voltage. Well, that one can just go straight on. It could just be that the speaker doesn't work. Alright, we'll put that back in there. It is the worst speaker to be using for this. But I want it to have its moment on camera. 12. Right. That literally, I'm pretty sure is the picture. I'm just double checking here. So 212, 1113. No, just say 40 ohms speaker. Meh, it's not going to make any difference. Okay. Well, that's just not fun. Alright, well, we just wiggle the wires. What we will do is we will just test what the voltage is going across. Is there anything that we can pick up going across the terminals on this thing? It's a pretty small voltage. It's not even picking that up. Well, it's not really going to show anything because it's not. Put it to AC. I've gone and put away my little oscilloscope thing, so I can't see what's happening. So we just had to finish it there. That was pretty disappointing. I always like it when something cool happens, but it's not going to be cool tonight, is it? Because I can't test it otherwise, can I? So you can just right. Maybe we take that out. How does this work? I mean, that's pulling it low. Oh yeah, that makes sense. Alright. Still think it should work. And that one's going to there. That one's going to there. I'm just looking one more time. One more time. Output. The output's the red one. It's going to there. It's going through there. That's pulling it low. So it's a MPN open collector type output, I believe. So it pulls the speaker low. Do I have anything else on the desk that might possibly work? Oh, no, I don't have any other speakers around. This is a shame. Okay, I want it to make a beeping sound. Well, it mostly works. I mean, we got there in the end, right? So thanks for watching. There was a blue LED. That was worth it. The whole thing was worth it for that blue LED. Wait. I almost heard something. Oh well, it's over. Oh wait. Where did I put them? Where did I put it? Alright, well we can test the speaker. We have 2 minutes, we can do this. These are not coded the right colored the right way. Ground, VCC. What did I push in the thing? Blue to ground. Yes, I have to do everything at once. Maybe, just maybe, we can drive the speaker from the output of here. Maybe I shouldn't even put anything in the... Well, the speaker works. Okay, that's my little 555 timer thing. So what if we just drop it down a little bit? What did I put it up to? How is that actually going to work? Like, I don't know. I feel like there should be something else for the speaker. Maybe I should look up the application note. What if I just put it straight on to here? Oh my goodness! Right, that's not actually lined up. Hey, there we go. It wasn't actually lined up with that thing. So we've got 45 seconds left. You can barely hear it, but it does actually work. Alright, what do I put it on there? Alright. Alright, quiet. Oh no, we're running low on water. It's all evaporating. We need more rain. Well, I should have said that after the beeping sound. But that was funny. It's always pays to double check that everything lines up on the breadboard. So they didn't line up on the breadboard. So thanks for watching. I'm so glad that this poor little speaker still actually works. It's had such a hard life. Alright, bye.